Hello everyone, welcome back to my channel. It's me Abhay speaking. So today we are going to the final part of basic mathematics and the second half of calculus, which is integral calculus. And this video is a continuation of a previous video, which is differential calculus. So without wasting any more time, let us go into this chapter. So in this video, what and all are we going to learn? What is integration and its uses, basics and its notations, formulas, all the basic formulas, methods of integration, what is its significance, and at last I am going to teach you a shortcut trick. Clear? Next, what is integration? Let us see now. Assume you have a large amount of infinite stakes. Now, the process of converting these large amount of infinite sticks into a rectangle or any certain shape of its kind is called integration. So basically, what are you going to do over here is you have large amount of small tiny sticks. What are you going to do? You are going to take a glue, attach, take glue, attach, slide, attach, apply glue, attach them, apply glue, attach, so on. What is it going to create? This shape. So this is what you are going to do in integration. Clear? Now, what is its use? Assume, okay, you have a ring and a person or a charged particle is over here. Okay, in basics of physics, I already taught you that this will exert force which is directly proportional to distance, correct? So here you will have some force, here it will exert some force, here some force, here some force. And if you want to find total force, okay, what are you going to use? You are going to use integration. Clear? Let us go to the next part. Now, let us talk about its notations and basics. Okay, this purple symbol which you are seeing over here is nothing but integration symbol, integral symbol. Okay, I'll write it over here. So it is integral symbol. What is this f of x which I have written? Which is what? Function to be integrated. Function to be integrated. Now, what is this blue part which I have written as dx? Dx, which means integration of a function with respect to x. Here, integration with respect to x. Okay, assume I write integral f of y dy. What is it? Integration of a function with respect to y. Okay, if I write integral f of z dz, what is this? Integration of a function with respect to z. Do you remember in differentiation I was telling d by dx differentiation with respect to x, d by dy differentiation with respect to y. Okay, it's similar only. Okay. Okay. Now what is this small a? This is nothing but lower limit. What is this? Lower limit. And what is B? B is called as upper limit. B is called upper limit. Is this clear? Copy it down quickly. Let us go to the next slide now. Now we learn some basic formulas. Here you have some formulas. It is what? Integral x power n dx is x power n plus 1 divided by n plus 1 plus c. Okay. Now, what is this c? Okay. Now, one more thing which you might have noticed is integration and differentiation are opposite. Okay. Are opposite. Did you see in this slide where what we did? We converted this infinite amount of small sticks into a single shape. What were we doing in differentiation? The opposite, na? In differentiation, we are converting this whole piece into small, small, small pieces. And in integration, we are doing the opposite. Clear? Now, integration and differentiation are what? Opposite to each other. Correct? Now, what does that mean actually? If we differentiate this function, you should get this function itself. Correct? We should get this back. Okay? We'll see. Now, let us differentiate. In x power n plus 1 divided by n plus 1 plus some c. C is what? Some constant we can have. I will explain the purpose of this c also. First, what we'll do? Differentiate this. What is it? Bring this power down. 1 by n plus 1 is what? Constant. Take it outside. Now differentiate x power n plus 1. Or is it n plus 1? Okay. Now, what we'll do? Decrease the power by 1. N plus 1 minus 1 plus differentiation of a constant 0. So this is what? This and this gets cancelled. So you have got what? X power n only. Second part, why do we use C? Okay, assume you have, when you have a function and you integrated that function. Okay, let us say you got x square plus 3. And let us say one more function you have x square plus 5. What is it? When you differentiate these two functions, what are you getting? 2x. But when you integrate this same function, what are you getting? Integrate. Let us integrate now. X power 1. What is it? Increase the power by 1 in the numerator. Divide it by this power. So which is x square. Is x square and x square plus 3 and x square plus 5 same? No, that is why you are using this integration constant. Clear? See the other formulas. Integral sin x is what? Minus cos. Integral cos sin. E power x is what? E power x only. Integral secant square tan. Integral cosecant square is what? Minus cot. Integral tan is log mod secant. And integral cot is log mod sin. And this is very, very important. Integral 1 by x dx is ln x. What is ln x? Ln is nothing but log of a base e, or log of x base e is written as ln x. Okay. Now, there are some more basic formulas, which is what? Let us say you have to integrate f of x plus g of x with respect to x. How are you going to do? Plus or minus, if you take, you can integrate them separately, just like differentiation. Okay, clear? But integral f of x into g of x is not equal to integral f of x dx integral g of x dx. Okay, this is wrong. Okay, this is what? Completely wrong. This is completely wrong. Don't do this. Okay, here you don't have a formula as such for this type. See, in differentiation you had what? U v rule, u by v rule. Here there is nothing like that. That is why we have methods of integration. Clear? Now, here we have something called as chain integral. In differentiation, you had something called chain rule, which was applicable to all functions. But this chain integral is applicable only to linear functions. Linear function, which means what? X power 1 only. What does it say? Let us say you have integral sine of nx. How do you do? Integral sign is what? Plus cos or minus cos? Minus cos. What do you do? Nx you have over here. keep nx only, but this time here what is there n? What you do, just divide that function by plus c. Here. Now, here is a quick shortcut for whoever gets confused for integral sign is plus cos or minus cos. Sign, you can assume it as sin, which is like mistake. And if you combine all the mistakes into one, it becomes a bigger mistake. So, which is negative. Clear? Negative. Okay, you can remember it like that. I used to remember it like that only. One more. Integral cos of nx. Cos is good. So plus sine nx. N is there. Divide plus c. Integral e power nx. Same. E power nx by n plus c. Okay. The proof of this, I will be explaining it in substitution method. Okay. I'll explain the proof of this in substitution method. Clear? Now, remember this. This is applicable only to linear function. So, what are the methods of integration? Let us check it. So, here we have three methods of integration, which is what? Using basic formulas. The formulas which I discussed, integral sine, integral cos, integral 1 by x, all those things, using that, you can integrate. Second thing, using trigonometric formulas. Okay, both 10th formulas and 11th formulas, and something called a substitution method. Okay, you have three methods. So we'll go through all the methods one by one. No. First, through basic formulas. So directly we'll solve some questions. Give it a pause and try it by yourself. So what you have to do, integrate it with respect to x. So let us see how to do. So what I can do, I can split it separately. Integral x square dx plus integral line by x dx plus integral 12 dx. Now what I will do? I'll apply the formula. Integral x square is nothing but integral x power n only. It's of the form integral what? X power n. Now, what is it? X power n plus 1 by n plus 1. Correct? X power n plus 1 by n plus 1. Correct? What is n? N is nothing but 2 over here. N is nothing but 2 over here. So it is 2 plus 1 by 2 plus 1 plus 9 is constant. Take it out of the integration. Okay. Integral 1 by x. Integral 1 by x is x power minus 1 dx. Here is what? 12. Take 12 common. Integral of dx is what? X. Remember this. Integral of dx is nothing but x. Okay. Integral of dx is x. So I'll write it directly. Okay. X. I will write c at the last. Okay. Now, what is it? X cube divided by 3 plus 9. Shall I write it directly? X power minus 1, which is minus 2, divided by minus 2 plus 12x. That's it. Try the second question on your own. Okay. Let us solve the second question. Again, integrate them separately. Integrate this separately. Integrate this separately. Integrate this separately. Integral sign is what? Minus cos. Okay, plus a I forgot. Yeah. Integral sign minus cos plus 8 I took it outside. Integral cos is what? Sine. Okay. Plus integral x power 1 is what? 1 plus 1, 2 by whatever this power is the same thing. Let us move to the next part, which is what? Trigonometric formula. Now the questions which you are going to see cannot be solved by using direct formulas, which you learned earlier. So you have to do some manipulations, which you're going to learn. Okay. First, for sine square and cos square, how do you integrate those things? Let us see. First, we'll see how to integrate sine square and cos square. Okay. Whenever you have a function which has sine square and cos square, you are going to use the formula cos 2x. Okay. You're going to use the formula cos 2x. Remember, there is no chain rule. Okay. Cos 2x, which formula? You have two formulas if you remember. Okay. Which is what? 2 cos square theta minus 1. 1 minus 2 sine square theta. Okay. Using these formulas, you will do some little bit of manipulation and you will solve. Okay. I will explain it to you how what manipulation you'll be doing. Assume you have sine square. Integration sine square. Let us see how to solve this now. First, what do you see? You saw sine square. So you will use cos 2x formula. Cos 2x is what? 1 minus 2 sine square x. Okay, you want sine square. What I will do? I will take cos 2x. I will take cos 2x this side. So 1 minus cos 2x is nothing but what? 2 sine square x. I will take 2 down. So sine square x. Don't you think I can write it as 1 minus cos 2x by 2? Okay. 1 minus cos 2x by 2. Now basically what? I had to integrate sine square. Now I can integrate this sine square now. Apply integral on both sides. What you can do? Just to split this. Now it's easy. Integral 1 by 2 dx minus integral cos 2x by 2 dx. Okay. Now integral 1 by 2 outside, integral dx is nothing but what? X minus 1 by 2, again you take it outside. Integral cos of nx is what? Sine of nx by n. Correct? By 2. What will add? See. So what is it? Nothing but x by 2 minus sine 2x by 4 plus c. This is the answer. Okay. Try cos square x integration by yourself. How do you integrate sine cube x and cos cube x? Which formula do you use for sine cube x and cos cube x? You for sine cube x you use sine 3x formula, and for cos cube x you use cos 3x formula. Okay, clear? I hope all of you remember the formula. If you don't know, I have discussed it in my basic maths video. Check it out. Basic maths part 1. Okay, now let us take cos cube x. This time. Let us integrate this. How? Let us see. I will use cos 3x formula. So what is cos 3x? 4 cos cube x minus 3 cos x. Correct. Now what I'll do? I will transpose it. So basically, shall I write it directly? Cos cube x. I will write it as cos 3x plus cos x plus 3 cos x whole divided by 4. Basically what I did, I bought 3 cos x that side and divided by 4. So I got this. Now what I will do, I will apply integral. I will apply integral on both sides. Now, what is it? I will take 1 by 4 outside. I will split the integration. Cos 3x by 4. Oh, sorry. Only cos 3x plus dx is there, okay? and 3 cos x. Now, what is it now? 1 by 4. Okay. Integral cos of 3x is what? Sine of 3x by 3 plus 3 is constant. Take it out. Integral cos is what? Plus sine x. What is there left? Plus the c. That's it. So, this is integral cos cube. Try the similar for sine cube. Okay. Now, let us go to the final method and the most important method called substitution method. Okay. This substitution method is used whenever you can't use the first two methods which I discussed. Okay. So you have to go in that order. First, you have to check if you can directly do it by basic formulas. If not, check if you can use it, do it using trigonometric formulas. Again, if you can't do it, go for substitution method. Okay, let us see. Here, I will explain using an example. How do we do this question? How do we solve this question? Listen to me very, very carefully. You have to integrate e power sin x cos x dx. So first, what you have to do is you will see this. You saw sine and cos. Okay, there is no sine square. There is no cos square. So there is no sine square. There is no cos square. There is no sine cube. No cos cube. You don't know e power sine x integration. Okay, you don't know integral f of x into g of x integration. So when you saw so much, you should have understood you have to use substitution method. How do we go about this? Here is how I go about. Whenever I see e power sin x, I feel little uncomfortable. Even you feel little uncomfortable. E power x you can integrate, not e power sin x. So let us do one thing. Let us take sin x as t. Let sin x is equal to t. What you will do? Differentiate with respect to x. So cos x is equal to dt by dx. I will take dx directly over there. So cos x dx is equal to dt. So basically what you can do is you can skip this step. Okay. Differentiate with respect to x, add dx, differentiate with respect to t, multiply with dt. Okay. This will save you one step. Now cos x dx is dt. Okay. But this is what you find it over here, na? Ooh, interesting. So, what is it? Sin x is what? T. Now, cos x dx is dt. Integration of a function with respect to t. Integral e power t is nothing but e power t plus integration constant. Now, what is t? Sin x. Bring it back. When you are coming back to the answer, you should have the same variable which you had initially. Okay, so bring it back to sin x. So this is how you integrate using substitution method. Okay, it requires some practice. Okay, let us solve one more question. Proof of chain integral. Okay, before going for another question, let us prove chain integral. Okay, I will prove only one of them. You can prove the rest. Let us say you have to integrate integral sine of nx dx. What you have to do, take nx as t because you know sine x right integral. So should I do directly n x t differentiation is what? Differentiation of x is nothing but 1 is equal to dx is there over here is equal to dt. Now, n dx is nothing but what? dt. dx is nothing but dt by n. Now, dx is over here. What I will do? I'll take it as sine only. It is sine. Now nx is what? T. Dx is nothing but dt whole divided by n. So it is nothing but 1 by n. Okay. Integral of sine of t is nothing but cos of t. Now what is it? T is nothing but nx by n. Okay. Integral sine is what? Minus cos. Sorry. Minus. Yeah. That's it. Clear? This is the proof. You can do the same for e power nx. Same. You do what you have to do. Take nx as the integral cos of nx. Take nx as t. Clear? Next. Here is another problem. Try it. I hope all of you have tried this question. Let us solve this. Now, how do you solve this question? Again, whenever you have like u by v, okay, try to take numerator as t first. If it works, then fine. If not, take denominator as t. Okay. Now, let us take numerator as t first. Let x square is equal to t. Let us see. So 2x dx dt. Okay. But it doesn't seem to be that helpful. Okay. So what we'll do? We'll try denominator as t. Take 9 plus x cube as t. Differentiate both sides. It is what? X. Sorry. Yeah. So differentiation of the constant is 0 plus this is what? 3x square dx dt. Do you see something? X square dx is there, but 3x square is not there. Let us do one thing. X square dx is equal to what? Dt by 3. Okay. All you have to do now is what? Just put the values. That's it. X square dx is nothing but what? Dt by 3. I will take 1 by 3 outside the integral. Okay. You can take constant out of the integral. 9 plus x cube is what? Nothing but what? T. Okay. Here you have d. Okay, dt is there. Now basically what? Integral 1 by t ln of t. So what is the t? 9 plus x cube plus c. Is this clear? Tell me. That's it. What did I do? I got ln t, but t I put it as 9 plus x cube. Okay. Now similarly, if you have 1 plus 9 plus x dx, how do you do? Take 9 plus x as t dx dt. You got it. Now, what is it? Nothing but integral dt by t ln t. This is what? 9 plus x. So basically, if you have a linear function like dx by 12 plus x or dx by some constant plus x, okay, what you can basically do is write ln plus that function. One next one. If it is 2x, 3x, or 4x, then you have to use substitution method. Clear? This is one more question. Try this question now. How do you solve this question? Try numerator as t x. Let us do this again very, very quickly. Take x as t. You got dx as what? dt. Okay, but it doesn't seem to be helpful. Okay. Now what shall we do? Denominator as t. Okay. Listen to me very, very carefully. What I am doing, whenever you have a root, don't take root of 1 plus x square as t. Instead, take 1 plus x square as t square. Okay. Take 1 plus x square as what? T square. Now, what you should do? Again, differentiate both sides. Differentiation 1, 0. This is nothing but 2x. This dx is there. Is 2t dt. Okay. Now, x is there, so x dx. Okay, 2 cancels anyways, so it doesn't matter, na? Yeah. So basically, x dx is t dt. X dx is what? T dt. So what do I do? X dx, I'll take it as t. This is dt whole divided by root of 1 plus x square. Root of 1 plus x square. T square. Square root and square cancels. So t dt by this is what? T. T cancels. You get integral dt, which is what? Nothing but t. And what is t? T is nothing but root of 1 plus x square. So which is 1 root of 1 plus x square plus 3. That's it. Is this clear? Tell me. That's it. This is the one of the most difficult questions of integration which you can get in physics, okay? In physics I'm talking about. Okay? In class 11th and 12th. Okay? Okay. Clear? Done. Now try this question as a homework. Okay? Try this question as homework. Copy this question down and try this question as homework. You should be able to do this question on your own. Now, let us go to the final part. Significance. What is the significance of integration? We learned so much about integration, correct? We learned so much about integration. What is the use studying so much about it? Let us see. First of all, what does integration represent? Understand. Integration, it represents area under the curve. Integration represents area under the curve of a certain graph. Let us take for an example. Okay. Assume you have a graph. Assume the graph is kind of like this. And they say find the area. Okay. From this point to this point. How do you do? Do you know the formula to find the area under this? No. That is why you use integration. This is lower limit. This is upper limit. Lower limit and that is upper limit. And this is the area under the curve. Okay. Now, I will apply a limit and let me solve a problem by applying limits. Okay. Let us say you have to integrate x square from 1 to 2. Listen one more thing. Integral f of x from a to b is nothing but what will integrate a function. Let us say after integrating you get a new function capital F of x. What is it? It is nothing but upper limit f of upper limit minus f of lower limit. Is this clear? F of upper limit minus f of lower limit. Now, let us solve this question. Integral x square is nothing but what? X power 2 plus 1, 3 by 2 plus 1, 3. Now, what I'll do, I will apply limit from 1 to 2. Now, put x is equal to 2. 2 power 3 by 3 minus 1 power 3 by 3, which is not nothing but what? 8 by 3 minus 1 by 3, which is what? Yeah, that's it. Let us talk about a shortcut trick. Okay. Now, Okay. Let us talk about a shortcut tree. Assume you have a graph. Okay. And let us say you have a function f. Let us say you have another function g. Listen to me very, very carefully. If f into g is some k of x, okay, and they ask what is the value of k of x from some point A to some point B, which is what? Nothing but area under this curve. Understood? Okay. Okay, I know you would just understand. Let me give you an example. So, you know, basic ninth standard physics, correct? So, you know that distance or displacement is velocity into time. So, this is velocity and this is time. Okay. And let us say you get some graph like this. And they ask displacement in first 10 seconds. What you have to do? You have to just find area under this graph. Is this clear? Very good. That's it. This is a quick shortcut. Okay. This is going to be used in physics. Here is a quick question. They have given you this function. That white line is f of x. Okay. First question is find integral 2 to 4 or 0 to 2 f of x dx. Okay. Second, integral 2 to 4. Okay. Third one, integrate it from 0 to 6. I will solve one of them. Okay. You solve the rest and tell me in the comments. Okay. Now, first part 0 to 2, which means not integration means area under this. So, what is this area of a trapezium? So, area of a trapezium is what? Half into base into sum of parallel sides. Half into base into sum of two parallel sides. So, which is basically what? Half into. What is its base length? This is its base, which is 2 into sum of two parallel sides. Okay. This I have not written. Take it as 6. Okay. What is it? Nothing but 6. This length is what? 6. And this length is what? 8. 6 plus 8. Cancel. Cancel. What is this? 14 units. That's it. So what is it? Nothing but answer is 14. Now, similarly, try it for these two questions and tell me in the comments down. Clear? Bonus questions. Now, in previous chapter differential calculus, I had given some bonus questions and some homework questions. Answer to those questions I have recorded in a separate video. But listen to me carefully. If you want that video solution, all you have to do, I want to know that you have tried to solve it. So, take a pic of your working, send it to my Gmail, which I have listed it down in the description down below. As soon as you send it, within an hour or two, I will be mailing you the video solution of that, plus bonus question of this integration chapter. Okay, and plus answers of the homework questions. Okay, so with this, I will conclude the differentiation chapter, and this also completes our basic mathematics series. And the next series is nothing but vectors. Vectors is a huge topic, so I will be starting it as a series. I will be doing it part by part. Okay, so that's it. Thank you for watching. If you have any doubts, let me know in the comments down below. Thank you.